first function here is a quadratic. And for a quadratic, the domain is going to be all real numbers. For the range, we have to find the vertex. So this is in vertex form. So we know that the vertex is going to be 3, 1, and that this graph opens up. So if it opens up, my range is going to be y is greater than or equal to the y value of my vertex, which is 1. Okay, next to it, we have a radical function, and it's a square root function. We know that the square root, the radicand can't be negative, so we're going to set the radicand to be greater than or equal to 0. So x minus 2 is greater than or equal to 0. So when we solve that, we get that the domain is x is greater than or equal to 2. If we plug 2 back in, 2 minus 2 is 0, square root of 0 is 0, 0 plus 5 is 5. So the range is going to be y is greater than or equal to 5. This graph goes up, so that's why it's going to be greater than or equal to and not less than or equal to. The next function is a polynomial, and it's a quintic. So when you have a quintic, domain and range, all real numbers. Okay, and the next one is a cube root function. So if you have a cube root, domain and range are again all real numbers. And the next one is a rational function. So since this is a rational, we have to factor the top and bottom, and then see what our restrictions are in the bottom. So the domain is going to be all real numbers except for our restrictions. Okay, and in this case, the restrictions would be -3 and -1, and that's from factoring the denominator. If you take out the -4 from the denominator, you're left with x squared plus 4x plus 3. So multiplies the 3 and adds to -4. You're going to use -3 and -1. So you set those to 0. You set those to 0 and you get 3 and 1. So, oops, my bad. So x can't be 3 and x can't be 1. Then for our range, we look for the horizontal asymptote. So the degree is 2 on the top, 2 on the bottom. So we're going to look at the ratio of the coefficients. So 1 over -4 gives us -1/4 as our horizontal. So our range is all real numbers, but y cannot equal -1/4 because that's our horizontal asymptote. And the next one is a linear function because you have an x and a y. So with a linear, domain is all real numbers, range is all real numbers. Next one is a polynomial, and it's a quartic because it has a 4th degree. So quartics have a domain of all real numbers, but for the range, we have to find the max or the min. So this is going to open up like this. So it has minimums. So we would just have to use the calculator here to find the minimum. And we want to find the lowest minimum, and then that y value is going to be part of our range. So since it opens up, we know that y is greater than or equal to. And then if you solve for that minimum in the calculator, it would be -4.494. So you wouldn't have to do this by hand. You would get a calculator to do this. Okay, and then the last one is another rational. So this is a rational, and we would factor the bottom. So let's take out the 3 in the bottom. We have x squared plus x minus 6. X plus 3, x minus 2. So our restrictions would be -3 and 2. So our domain is all real numbers, except x cannot equal -3 or 2. For our range, the degree on the top is 0, the degree on the bottom is 2. So y equals 0 would be our horizontal asymptote. So our range would be all real numbers, but y cannot equal 0. So all real numbers, y is not equal